Assalamu alaikum. Welcome back to the course of Digital Logic Design. Today our topic is Mealy and Moore model of sequential logic circuits or finite state machines. As we know that the general model of a sequential circuit has inputs, outputs and internal states of the flip-flops. So based on it we have two models of sequential logic circuits as given below. The first one is the Mealy model and the second one is the Moore model. In the Mealy model, the output is the function of both the present state and the input. Here we can see the block diagram of a Mealy model, where the output is the function of the internal state or the present state available here at this point, and also the function of the inputs. So the output depends not only on the present state, but it also depends on the whatever value is available at the input. The example of a Mealy model can be given as here. We can see that this model uses D flip-flops to define the internal states of the circuit. Here the output Y is the function of the internal state A of t of the first flip-flop, B of t of the second flip-flop, and also the complement of the input. So this model can be referred as the Mealy model of the sequential circuit. Coming towards the second model of the sequential circuit, which is called the Moore model. In the Moore model, the output is a function of only the present state. Here we can see the block diagram of a Moore model, where the output only depends on the whatever state is available at this point. It does not depend on the input. So here the output is synchronized with the clock, because it only depends on the whenever there is a change at this point, and this totally happens when there is a clock edge change at this point. But in the Mealy model we have a synchronization problem, because the output depends on the present state and also on the inputs. So for example, after a clock edge we have a certain output here at this point. So the clock is positive, negative, positive, negative. So if this circuit is for example triggered with the positive edge of the clock pulse, so here we will have a certain output. Meanwhile, if the input change, the output will also change, and that is why we have synchronization problem of the present state with the inputs. So there is a need of synchronization between the flip-flops or register with the inputs, such that the change must be synchronized with each other. Also, the output must be sampled immediately before the clock edge occurs. As we know that as the clock change will occur, then the output's value will change. That is why we need to sample the output values before the clock edge. Thank you.